Okay, so here is the scribblecast on pOH as opposed to pH. We'll go through the same kind of routine and formulas as we used with pH, and they're very similar. We basically use the same formula, just change hydronium ions to hydroxide ions and pH to pOH. So it's very similar. So in this one, we want to be able to calculate, oh, not pH, well, pOH, and not those guys, but hydroxide ions. And I guess maybe at the end of this, it might be interesting to, if I know hydronium ion concentration, how would I be able to figure out the hydroxide ion concentration? Here's symbols for concentration. How would I go from one to the other? Turns out that you could, if you know hydronium ion concentration, you could figure out pH. Then if you know pH, you'll know pOH. And if you know pOH, you'll be able to find hydroxide ion concentration. There is a direct way, but often we sort of go to the indirect way. Anyway, we'll look at relationships with all of those. Let's go back, though, to the definition, or what pOH is. And pOH, as we saw similarly to pH, it's a log scale, and it's relating, or it gives relative strengths of pOH of, I guess, acids or bases, but specifically we're looking at bases. So if you see pOH, think base. It doesn't mean it's a base, but typically it's a scale that's used for bases. And typically pH is a scale that's used for acids. Again, same scale here. So if I have a pOH of 1, that is bleach, something that is awfully powerful. You can try that, like I said in the other scribblecast, in the acid-base one. Try that. Take some bleach, put it on your tips of your fingers, and just roll it around with your thumb, and you'll find it's very slippery. Do that for, I don't know, half an hour, an hour, and you'll find the skin starting to wear away on your fingers. You may not want to try that. You may want to just trust me on that one. Again, you can look up other substances that you have around the house or anywhere and look for their pOH. So when we are wanting to calculate the pOH from a particular substance, what we need to find is its hydroxide ion concentration. If I know its hydroxide ion concentration, I can determine, oh, this is incorrect, I can determine the pOH of that solution. Okay, so let's try a question. Here's one. That's interesting. This formula is wrong. This should be pOH. That's okay. So the formula is pOH equals negative log of hydroxide ion concentrations. So the question is, calculate the pOH given it has that concentration of hydroxide ions. All right, so pOH is equal to negative log of my hydroxide ion concentration is that moles per liter. So I break out the trusty calculator, and hopefully mine's still working, and I go negative log of 0.022 bracket, bracket equals. Okay, so my pOH of that solution is 1.657577, etc. Again, I'm given 2 sig figs here in this concentration, and so in my pH I need to give 2 decimal places, or my pOH I should say. So the pOH to the correct number of sig figs I need to give 2, so it'll be 1.66. That'll be the pOH of that solution. Okay, and I think that answers their question. Now another question I could ask is, what is the pH of the solution? And you'd say, oh, thanks for the extra marks, because you know that pH plus pOH is equal to 14. So if I want to know the pH of that solution, all I have to do is go 14 minus the 1.66. So I'll get 12.34, I think. So the pH of that solution would be 12.34. The pOH of that solution is 1.66. So the pOH is getting close to 0. The closer it gets to 0, the more basic the substance is. If I have a pH, like in this case here, I have a pH of 12.34, it means it's not very acidic. Well, it's not acidic at all. It's actually basic. And that's what the pOH is telling me here too. Okay, now similarly with pH, we also need to go backwards. Well, maybe before we go backwards, why don't you try a couple? Okay, do the pause thing and try these 3 questions to see if you can figure out what the pOH of solutions that contain these concentrations of hydroxide ions. Okay, pause. Okay, you're back. If you didn't pause, that probably sounds funny. Anyway, see if those are the pOHs that you got from those hydroxide ion concentrations. If they're not, you may want to come and chat with your instructor, get some help. Make sure you can do those calculations. Okay, now let's go backwards. Okay, so I now can take hydroxide ion concentrations. Whoops. I can take hydroxide ion concentrations and I can determine pH. But I have another formula. Notice that it's real similar to the one that we did in pH, that can take any solution, if I know its pOH, and convert that to hydroxide ion concentration. For example, I have a solution with a pOH of 4.5. Notice 1 sig fig. If I have a pOH of 4.5, then I should be able to figure out the hydroxide ion concentration. Remember, the pOH is just a relative kind of number. It's a logarithmic scale. It's actually not a concentration. But from it, I can get a concentration using this formula. So the concentration of hydroxide ions in that solution is equal to 10 to the negative pOH. You know, I actually like to write the formula down every time, just as a matter of habit. So I write the formula, then I plug in my numbers. Negative 4.5. Okay, so off I go to my calculator. So I have to go 10 to the negative 4.5 equals. On my calculator, it comes out to, I only have 1 sig fig again, so this one is 3.16, etc. So I'm just going to write 3 times 10 to the minus 5. So that'll be the concentration of hydroxide ions in that solution. Again, you give it a shot. Okay, are you ready to pause? After you pause, I'm going to move the green square and you'll see the answers. Okay, pause. Okay, we're back, and hopefully these are the pOHs. Hopefully these are the hydroxide ion concentrations that you got on your own. Again, if you have troubles getting those numbers, come and chat with your instructor. Now again, remember that the sum of the pH and the pOH is equal to 14. So if they give you something that has a pOH of 3.3, it's fairly easy to find the pH just subtracting that from 14, or 10.7. I myself like to deal in pHs. pOH, I can handle that, but my head is screwed on, so I understand pHs real well. I know a pH of 1 is very acidic. I know a pH of 14 is very basic. So if they give me a pOH, so if they say, hey Jeff, you have a pOH of 9, I'm thinking, okay, is that acidic or basic? And I always have to go, okay, the pH of that would be 14 minus 9, or that would be 5. So there, it's less than 7, so this would be slightly acidic. That's sort of in my own mind how I have to rationalize things. I work real well in the pH world. The pOH world, yeah, I can do the calculations, but I have to convert it back to my buddy pH in order for me to know. Something that is 7 is neutral. If it's less than 7, it means it's acidic. If it's more than 7, it means it's basic. So this is a nice tool. If they make you deal with pOHs, you can quickly convert them to pHs, and then you're back sort of on the scale that feels like home. Okay, so we went through in this scribblecast looking at pOHs and moving them from a pOH to a concentration of hydroxide ions and back and forth. Okay, hope that helps out with acids and bases.